Welcome to the first lecture of ME 609, which is optimization methods in engineering. In this particular lecture, I will be covering an introduction. In this lecture, I have divided into 4 parts. I will discuss the syllabus and grading first, followed by introduction. Then we will move to problem formulation, and then there will be an assignment at the end. Let us begin with the syllabus and grading. In this particular course, we have major section like introduction and problem formulation, which I will be covering in this lecture. Followed by, we have single variable optimization algorithms. So you might have seen if the function is given as f of x is equals to x square, then this function is made of single variable. So when such kind of a problem comes into the picture, then what are the algorithm that can be used in with computer to solve those problems? Then comes multivariable optimization. Most of the engineering design problem involve multiple variables. So when we need algorithm dedicatedly for multivariable. However, you will realize that for solving multivariable optimization, we need help of single variable optimization algorithm. So in those algorithms, we will be covering one by one. Then comes constraint optimization, and you will realize the constraints are the part of all engineering optimization problem. When the constraints are there, the behavior of the problem changes. Therefore, we have different kind of optimization algorithm for constraint problems. Thereafter, we will deal with some specialized algorithm. And at the last, we will cover non-traditional optimization algorithm, such as genetic algorithm. The textbook for this course is by Professor Kalyan Dev, Optimization Methods for Engineering Design, Algorithms and Examples. I will be covering most of the part in this, course by this book. And there is another book by SS Rao, which is another good book, which I will be referring for some part. Regarding the project, it will be developing the codes of an optimization algorithm. I will tell you the algorithm for which you have to make the code. So everyone will be making codes for different algorithms. You can use any programming language such as C, C++, MATLAB, Python, etc. The mathematical problems I will be giving to you. For those mathematical problems, we know where is the optima. So you can always compare how is your algorithm working. And at the end, you have to prepare a report. The report should have a title, abstract, introduction, description of algorithm and flowchart. You have to, and then there is a resultant discussion. So you will be tabulating the result, comparing the result, convergence plot will be there, and you will be explaining all of them. Then you will conclude. For writing the report, I'm suggesting you to use IEEE template. So this website, if you go through it, you can download the Word template or the LaTeX template for writing the report. Now I'm starting the content of this particular lecture with an introduction. So what you can see that whether it's an industry, whether we are designing a product or we have a business, everyone is set up on a goal. So we decide the goal for those industries, and the goal is we have to either minimize something or maximize something. For some industries, they want to minimize the cost. And for some other industries, they can be maximization of a profit. So depending on the goal of the industry, product or a business, you will be either minimizing or maximizing. So for example, the aerospace design, these aerospace engineers will work on minimizing the weight of aircraft component. Similarly, mechanical engineers would be working on minimizing the cost of manufacturing or maximizing the component of a life. So I'm just giving you few example. However, the list is very long. Similarly, chemical engineers, they will look for optimum flow rate of production for a process plant, and process production engineer will be looking for optimum schedules for various machines to minimize idle time and job completion. Similarly, Civil engineers would like to minimize the cost or maximize the safety of civil structures, such as building, bridges, dams, etc. Electrical engineers would like to minimize time for communication from one node to another in a communication network. So there could be many examples from various fields where the optimization will be needed. What you will realize that all of these tasks, whether it is a civil engineer or electrical engineer, it involves either minimization or maximization of an objective. Along with that, there will be some restrictions. Those are called constraints. So we will discuss in detail after a few slides. Now let's come to the problem formulation. Now problem formulation, there is a naive approach. Now naive approach is that suppose we have few solutions based on, say, our experience. We have few 10 or 12 solutions with us with some prior knowledge. What we do here is we check the feasibility, whether this solution is feasible, can be implemented in my industry, can be implemented in my course, my thesis, my any problem where optimization is needed. If I check the feasibility, then if the solution is found feasible, then we look for objective function. So what is the objective function value? And when then afterwards, we will be comparing the objective function values of all feasible solutions, and then we choose the best. Now the question is, can we guarantee to get the optimal design solution? The answer is no. Why? Because those 10 or 12 solution uh, may not represent the optimum solution. They can be some solutions, and when you are comparing, you are choosing the one. However, the optimum solution can be at some other place, and that's why this kind of naive approach is not going to give you an optimum solution for all problem. So the remedy to the problem is use proper optimization algorithm to solve your problem. So what is optimization algorithm? It provides systematic and efficient ways of creating and comparing new design solutions in order to achieve an optimization design solution. So in this case, we start with some point, we create another new point, we keep on comparing. So we keep on searching and try to find out where is the optima using optimization algorithm. For using this optimization algorithm, we need mathematical model, and that is also referred as problem formulation for optimal design. What you can see is that since we are creating and comparing the new solutions, it is a time consuming task. Sometimes it is computationally expensive as well because it involves so many comparison. So therefore, the optimization algorithms are designed to run on a computer. Now there are some steps in an optimization task. So first we have when we are starting the optimization, the first question we have to ask ourselves whether there is a need for an optimization, because there are some problems that can be solved by simple simulation. In that case, when you are sure that yes, I need an optimization, then we look for problem formulation. So problem formulation, we will be looking for mathematical equations. In this problem formulation, it involves identify problem parameters. Then among those parameters, choose design variables. Then we have to formulate constraint and objective function using design variables. Then we set up the variable bound. If I'm working on a new problem, that work itself will require 50 to 60% of your effort. Once it is done, then we choose an optimization algorithm. So at the end of the course, you will be able to choose the algorithm based on the problem formulation and the characteristic of the problem formulation. Then we get the solution. If you are happy with the solution, we can stop it. If you feel that the solution is not as per what we desire, then we have to reformulate. So reformulation will be done at any step here and then rerun. And we are going to rerun and reformulate till we don't get a satisfactory solution. Typically, I can write an optimization problem as either minimizing or maximizing the objective function called fx. This particular problem can be subjected to the constraints like gax greater than 0, hx equals to 0. So this is called inequality constraint. This is called equality constraint. And then finally, we will be having design variables. So the value of x will be lying between lower and upper limit. Now let me begin with the design variable. So suppose if we are working in a new problem, new domain, then we have to first start with the design variable. So we have to identify those design variable. How we can do that? So design problem usually involves many design parameters. Now we have to find all of those design parameters related to the problem. Among those parameters, we will be looking for those parameters which are sensitive to our optimization problem. So this can be done either using sensitivity analysis, or we can use experience of the users. So those design sensitive parameters will become design variables, and other parameters we keep them as a constant in our formulation. Thereafter, we have to specify what kind of parameter it is. It can be binary, discrete, or real. Binary means it can take 0 or a 1, yes or a no, on and off kind of a decision. Discrete means suppose you have a gear. In that gear you have 6 teeth. Now the number of teeth will be an integer value. So it is discrete. You cannot have 5.5 teeth, right? So this is discrete. And then we have a real parameters that can take any value. So the first thumb rule of an optimization problem is choose as few variables as possible. Why? Because the efficiency and speed of optimization algorithm depends on the number of variables. So if we keep it less, then the efficiency and speed of an optimization algorithm will be good. Now let us move to constraints. Now let us understand what we mean by constraint. If there is a limit on certain resources or on certain physical phenomena that are represented by the constraints. So for example, in this pandemic, there were a shortage of some resources at one particular time. So that is putting constraints. Some example like stress and deflection limitation. These are putting constraint on our problem. And so we have to identify the constraint associated with the optimization problem. There are different types of constraint which you can find. First type of a constraint is called inequality constraint, which is Gj of x greater than or smaller than 0. And most of the engineering design problems involve inequality constraints. However, there can be an equality constraint as well. And it is important to note that these constraints are difficult to handle. So for example, we can have like deflection in the beam equal to 0.5. So this is an equality constraint. And if we want to include it, it is better to convert into the two inequality constraint as it is given here. So the deflection should be greater than 0.4, but it should be less than 0.6. So in this way, we can simplify our problem. So second thumb rule in the formulation of an optimization problem is the number of complex equality constraint should be kept as low as possible. Third is the objective function. Now the objective function can be minimization or maximization type. So the constraint and objective functions are made of variables, decision variables. Now what you will realize that most of the optimization algorithms are designed for minimization. And suppose my problem is maximization, then how I can solve it? So what I can do is I can use this duality principle, which says that minimum of fx is equals to maximum of capital Fx, where capital Fx is minus time. So if I just put a minus of f of x, the minimization problem just converted into the maximization problem. Now look at this figure. Now this is suppose a function and I want to minimize it, and you will get x star as our optimum solution. If I want to maximize minus fx, the curve will look like this dashed line. In both the problem, what you will realize that the optimum solution will remain the same, and therefore the maximization problem can be converted into minimization by just multiplying by -1 and vice versa. Lastly, we have to look into the variable bounds. Now here, let us assume that this X represents a vector of n variables. So x1, x2, xn can be different variables. So in mechanical engineering, if we are working on a lathe, it can be speed, feed, and depth of cut as x1, x2, x3. If we are in electrical engineering, having voltage and a current, suppose the variable, then x1 and x2 will represent voltage and the current. Similarly, in other field also you can have different variables. So we have to set those variable bounds lower and upper. So xil means the lower bound and xiu is the upper bound of xi variable. So what you will see that in subscript I is written because for each variable we have to decide the variable bound. Now let us take an example here and see how the problem formulation can be written. The manufacturer of the formulated medicine wants to prepare a production plan for two medicine, A and a B. The market demand of A is at least 1.5 times that of B, but the rate of bottling A to that of B is 1:2. There must be an inventory of 500 bottles of A at the beginning, and there is also a storage limitation of bottles 8,000. The profits on selling medicines A and B are 6 rupees and 8 rupees. Formulate the problem. Now so you remember that when the statement is given to you, we have to identify what could be our design variable. The hint what you can get is from the objective function. While reading this paragraph, you can make it out that we have a profit and we want to maximize this profit. So this means that our objective function will be based on the profit and it depends on 6 and 8 and it depend and 6 and 8 means how many medicines of A and a B will be selling. This means that if I am selling some number of A, then multiplied by 6 will become the profit earned from A. So this statement gives me an idea that the variable should be x1, number of bottles of A, x2 should be number of bottles of B. Now using these two variable x1 and x2, I can construct my objective function, which is maximize profit equal to f of x, which is 6 of x1 plus 8 of x2. Our objective is what should be the value of x1 and x2. Now, this particular problem, while reading this statement, there are certain restrictions. So what are those restrictions? So the first is called market demand. So the market demand is at least 1.5 times. So I can write x1 should be greater than or equals to, because the word at least means it should be either this one or it can be greater than. So x1 greater than or equal to 1 by 1 by 2 x2. And the rate of bottling is given as 1:2. So x1 is to x2 is 1 by 2, which is generally a constant. And if I take this constant, I'm just writing the equation for the simplification. Then there is another constraint on bottles. So the inventory of number of bottle A at the beginning is 500. So we will be writing x1 can be greater than and equal to 500. However, where the storage capacity is 8,000. So this means the number of bottle of A and a B should be less than or equal to 8,000. So that's why we are writing this. And what should be the limit on x1 and x2? X1 is already given as greater than 500. X2 should be greater than 0. However, it can take any value, but this constraint will keep the value of x1 and x2 not going to infinity, but certain value. So such kind of a problem formulation will be given to us and we will be deciding and we will be writing the problem formulation. Now coming to the assignment. What you have to do is the assignment 1 is a handwritten assignment. You have to upload on the Moodle. So after enrolling yourself in the Moodle, you just see this particular text upload assignment 1. So it will allow you to upload just one file. Be careful. Then what you have to do is you have to write just one function for every category and draw the following. And this should be your choice. So whatever you have learned from your class 9, 10, 11, 12, BTech, MTech, you have to decide your own function. So for example, non-differentiable function. So modulus of X is a non-differentiable function. So similar to that, you have to think of some function which is non-differentiable, at what point it is non-differentiable, and you have to plot it. Similarly, discontinuous function, where it is discontinuous, and you have to plot it. Nonlinear function, you have to think about what is C1 continuous function, what is C2 continuous function. Think about it and write it and plot it. The submission for the assignment is tomorrow, that is 5th September by 7 p.m. on Moodle. So please don't send me an email. You have to upload on the Moodle. If I found you have copied, I will give 0 to you. With that, I'm closing this session. So the lecture 1 on introduction and formulation is over. I will be uploading the next video on single variable optimization. Thank you very much.